Hello. Today we are going to talk about learning target number 11. And in this learning target, we are going to solve equations with variables on both sides of the equation. So let's go ahead. In this example, you'll see variables on both sides, a 3x on this side and a 4x over here. And the goal is to get all the variables on one side. It doesn't really matter which side we move it to or which one we move, but we want to get it all on one side so we can eventually get to the place where it says x equals. One trick I like to use is always moving the smaller of the two, and that way we typically end up with an x value. So here's the same equation, and once again we have a 3x and a 4x. Of 3x and 4x, obviously 3x is smaller. And in this case, it's a positive 3x. So the way we get rid of positive 3x is by subtracting 3x from both sides. Once I do that, these 3x's cancel because 3x minus 3x makes 0, and anything plus 0 is itself. We're going to bring the 2 straight down, equals. Now 4x minus 3x is 1x, so I'm just going to write an x there. And then also bring down the minus 1. And now we have a simple one-step equation. So you'll add 1 to both sides. These cancel, and we get 3 equals x, or x equals 3. Don't forget to check your work. Let's plug 3 in. 3 times 3 plus 2 equals 4 times 3 minus 1. So 3 times 3 is 9, plus 2 is 11. 4 times 3 is 12, minus 1 is 11. So indeed we did. Let's go ahead now and do another example. In this example, we have an 8y and a negative 3y. So the negative 3y is smaller, and the way we get rid of negative 3y is by adding 3y. So I'm going to add 3y to both sides. 8y and 3y make 11y minus 9 equals, these two cancel, and I just get left with 2. And now we have a simple two-step equation. So we add 9 to both sides. 11y equals 11. Divide both sides by 11. So y equals 1. Don't forget to check your work. 8 times 1 minus 9 equals negative 3 times 1 plus 2. This gives me negative 1, and so does this. So I know I got it. Now, you can ignore these choices over here. They didn't print correctly. Let's do this example together. Why don't you take a minute and do it. Please press pause on your video. Once you've solved it, then press play, and you can go ahead and check your answer. So press pause now. Okay, at this point you should have already solved the equation. I'm going to quickly go over what you should have done. We have a negative 4x and a positive 1x. Which one is smaller? In this case, negative 4x is smaller. So I am going to add 4x to both sides. I get 3, these cancel, equals 18 plus 5x, which is now a simple two-step equation. So now I am going to subtract 18 from both sides. These cancel. I get negative 15 equals 5x. I'm going to divide both sides by 5. And I get x equals negative 3. Hopefully you got negative 3 as well. Just in case, I want to show you what would happen if you actually moved the other x to the other side, just in case you mistakenly couldn't tell which one was smaller initially. So let's go ahead and redo the problem, but this time moving the other one. If you had subtracted x from both sides, you would have gotten 3 minus 5x equals 18. Now, once again, you're at a two-step equation. Subtract 3 from both sides. You get negative 5x equals 15. Divide both sides by negative 5. And once again, x equals negative 3. So you can really see it doesn't matter which x you move. But again, I like to move the smaller one. For this next example, you're going to do it on your own, and these are the choices of answers: negative 14, negative 13, positive 13, or positive 14. So once again, pause your video, solve this equation, and when you finish solving it, go ahead and press play again to check your work. Okay, so the first thing you want to do in this equation is distribute. So when I distribute, I get 3x plus 12 equals 2x minus 2. And that, again, gives me variables on both sides of the equation. The next thing I want to do is decide which one's smaller, 2x or 3x. Obviously, 2x is smaller, so I'm going to subtract 2x from both sides. That will give me x plus 12 equals negative 2. Now it's just a simple one-step equation. Subtract 12 from both sides, and I get x equals negative 14, which is the first choice. I hope you got that. In our next example, we have a lot of fractions, and I know in the fraction problems we've done so far, my suggestion has been to multiply by the reciprocal, but in this case, how would you choose which fraction to use? There are so many different fractions, it's hard to decide. So one trick that we'd use in algebra is to multiply through the entire equation by the least common denominator, by the least common multiple. So what you want to do is you want to look at the denominators, and there are three different denominators, 8, 4, and 2. And if you had to find a least common denominator, it would be 8 in this case. So we're not really going to use least common denominator, but you're going to use that same number to make this equation much simpler. So I'm going to rewrite the equation here just to make it a little bigger. And what I'm going to do is I'm going to multiply through the entire equation by 8, because that would be the least common denominator. And when you multiply through, you have to multiply everything through, not just this or that or one thing or the other, but every single item. So I'm going to multiply this fraction by 8. I'm going to multiply this fraction by 8, this fraction by 8, and this item by 8. And now I'm going to actually simplify them. So 8 over 1 times 3 over 8 is going to be 3. If you want to use my trick, 8 divided by 8 is 1 times 3 is 3, so that's just going to give me a 3. 8 over 1 times 1 over 4 is going to give me a 2. 8 times 1/2 is 4. And 8 divided by 4 is 2 times 3 is 6, or 8 over 1 would give you 24 over 4, which again is 6. So you can see that just by multiplying through by an 8, I've gotten a much, much simpler equation to work with. I don't want to work with all those fractions because I don't want to make a mistake. But if I multiply through, it's going to be much simpler. So now I'm going to go ahead and use my new rules. I have a negative 2x and a positive 4. So which one is smaller? Negative 2x. So I'm going to add 2x to both sides, which is going to give me 3 equals 6x minus 6. I hope I did the math right there. And now I would add 6 to both sides and divide. So I'm not focusing as much on this problem on actually solving it. What I wanted to focus on for you was the multiplying through by the least common denominator. This is a really tricky problem, so if this one confuses you, don't worry, we'll do more of these together tomorrow. The next thing I want you to look at is what we call special cases, and there's 2 of these in solving equations. It's really important you pay attention in this example because you certainly will see more of these as we move further along in math. So let's go ahead and solve this one. In this case, I do have 2 x on one side and 2x on the other. So you're already probably thinking, how would you know which one to move? They look the same. And you'll see as we go to solve it, this does create a really interesting problem. So let's just go ahead and subtract 2x from both sides because that's what we would normally say to do. But you'll notice this cancels out and so does this. So all I'm left with is 5 equals negative 3. And you should all know that 5 never equals negative 3. There's no case in math where 5 is ever equal to negative 3. And when you get an answer like this, something that's not true or something that never happens, what we say is empty set or null set because there is no solution for x. There's no number that I could plug in that would work. And I know that because whenever I get one of these untrue statements, it means that there's no possible solution to x. So that's special case number 1. Special case number 1 is where there's no solution and we write empty set as a kind of a quick way to show that there's no special case. I'm going to do for you here is kind of the reverse of that. So let's go ahead and solve this and see what we get. The first thing you want to do here is distribute. So you get 3x plus 3 minus 5 equals 3x minus 2. And what I'm going to do now is combine these. So I get 3x minus 2 equals 3x minus 2. You're probably already thinking to yourself, wait a minute, 3x minus 2 equals 3x minus 2? That sounds the same. And that's true. Let's keep working just in case you don't believe me. If I subtract 3x from both sides in an attempt to get all the variables on the same side of the equation, once again, both things cancel. But in this case, we get a true statement. negative 2 is equal to negative 2, and that's always the case. And so what this means when we get an example like this is that no matter what you plug in for x, it will work. So let's go ahead and go up to our original equation up here. And if you look at this original equation, pick any value of x. Let's pick 1. If you plug in a 1, you would get 3 times 2, which is 6. 6 minus 5 is 1. And 3 times 1 is 3 minus 2 is 1. So that works. If you picked negative 10, it would work. If you picked negative 1,000,000, it would work. Any value that you pick for x is going to work in this equation. So the way we write our answer for this is x is an element of the set of real numbers. And the shorthand way we write that is by writing an x, by writing a curved e, which stands for the element of, and then we write a fancy r, which means real numbers. And you know what real numbers are. We studied those earlier. That's rational and irrational numbers. And that we word it this way so that everyone knows that the solution for x is everything real. Every real number is a possible solution for this equation. So those are our two special cases, one where there's no solution and one where there's every solution. Presentation. There is one more practice problem here if you want to try it. And if you want to pause your machine, we'll go from there. Thanks. Bye-bye.